Okay, so this just so happens to be the first method we're going to look at, the average pressure loss method. And one thing we need to account for are pressure losses due to devices, some backflow preventers, for example, water meters, any other devices that may be installed. Elevation, 1 psi will be lost for every 2.31 feet of elevation. And the metric equivalent we use is 10 kPa per meter of head for design purposes. So that's even at static conditions. Divide remaining pressure by the longest equivalent run. So we're going to look at the longest measured run of piping in the system and then add in an equivalent length to represent fitting losses. Take a look at that in a minute. So at the end, once we do our average pressure loss calculation, we have to have this remaining residual pressure available. What this is trying to account for here is the available pipe friction for the system. And if we can meet all these criteria, then we're going to be able to use the table A26312F in the appendix. So this table here is what we'll use to size the distribution system for the average pressure loss method. Just touching on the longest equivalent run again, the rule of thumb or the rough rule is that measured length is taken for the system and then we add 50% of that measured length to sort of accommodate all the fittings that may be in the system. That may be too much, it may be too little. Worst cases are usually what should be entertained. Some streamlined copper fittings, for example, may not require that much additional length to be added to the measured length of the system. But then again, some insert fittings for some different types of PEX installations, for example, may require higher than 50% to be added to the measured length. So manufacturers may have some recommendations on that as well. But the rough rule is 50% is added to the measured length to accommodate whatever friction loss there would be to fittings and valves. So here is that table A26312F in the appendix. It has 4 velocity columns available. The 3 meter per second column on the left, for example, might be used for some plastic products like polypropylene, CPVC, etc. The 2.4 meter per second column here, of course, is used for cold water and copper systems. 1.5 meters per second is used for hot water and copper systems, up to 60 degrees Celsius or 140 Fahrenheit. And for copper systems that have water that may exceed 60 Celsius or 140 Fahrenheit, typically 1.2 meters per second is utilized. So again, based on manufacturer's literature, we would select the velocity that would be appropriate. Here's the average pressure loss calculation that needs to be done. We're just going to go through an example here. Again, this table is in the appendix and it's very simple to use. So we'll just say, for example, there's 100 psi available at the property line, which will convert to kPa. So remember, 1 psi is equal to 7 kPa for design purposes. And we'll just say that we're going to lose 100 kPa, grabbing a random number there, through the service. Could be a little bit of elevation loss, maybe a few fittings that we incur. So we'll say that there's 100 kPa lost and that we're able to get 600 kPa to the building, and we'll carry that down here. So our adjusted pressure, what's available to the building, is 600 kPa. We'll assume we have a PRV set to 550. So if we have 600 kPa coming into the building and we have a PRV set to 550 kPa, we would have a pressure loss of 50 kPa. Deduct 50 kPa there. Losses for system height. So assuming we have, we'll call it 3 meters of system height, the calculation to do there is 10 kPa per meter of head. So we're going to lose 30 kPa just to lift the water. The minimum pressure available, or minimum pressure necessary, for fixture operation is typically taken at 105 kPa minimum. That's 15 psi, and that really is a bare minimum. Most residents, most people that use fixtures, shower head for example, would usually expect or anticipate, have an expectation, let's say, of more than 15 psi for satisfactory fixture operation. As a design minimum, 15 psi will work in our case. So once we subtract all these losses from 600 kPa, we get 415 kPa available. That's what's available for friction loss to the piping. So we're going to carry that down here to the next line, 415. The developed length of our system we'll say is 60 meters. Developed length. And we need to multiply that by 1.5. So we're going to increase it by 50%. 60 times 1.5 is 90 meters. So again, just to be clear, 60 meters was our imaginary developed length, but 90 meters will be our actual equivalent length. So we're going to divide the pressure that's left over after we calculated our losses due to devices and elevation. Divide it by the equivalent length of the system, and we come up with 4.61, which is kPa per meter. So that's what's available per meter of our system, or at least the equivalent length of our system, to be lost to friction. As long as we exceed 2.6 kPa per meter, then the average pressure loss method can be used, the table can be used. If we're doing the calculation in PSI and feet, then the minimum is 0.115 PSI per foot available. If these minimums aren't met, then a detailed engineered calculation would need to be performed.